Corporate Finance OneNote Practice Problem. In this presentation, we're going to work a practice problem in OneNote related to compensating balance loan. Get ready, it's time to take your chance with Corporate Finance. Here we are in OneNote. If you would like to follow along in OneNote, you're not required to, but if you have access to it and would like to, we are in the 822 Compensating Balance Loan tab in the Practice Problems section. Closing this back out, we're going to have our information up top. We'll work through that information in the practice problem down below. Our basic scenario is that we would like $310,000 to invest in something within our business. We're looking for a loan for that. However, when we go to the bank for a loan, our scenario is going to be that the bank's going to say that we have some risk. There's some risk to the loan, and therefore the bank wants to do something to mitigate their risk. Typical things the bank will do to mitigate the risk of giving a loan: possibly increase the interest rate, or they might have some kind of fees, or they might change the loan structure. In this case, they're going to have a compensating balance requirement. And now a compensating balance requirement means that whatever the loan is, whatever loan amount we have, they're going to take 20% of it, and we want to put that in some way, shape, or form in some place that we can't basically use, so that the bank has a little bit more assurance that we'll be able to pay off the loan in the future. The bank can have some assurance that at least that portion can be used towards paying off, the loan in the future. So it's a way to give more assurance basically to the bank. So if we are in a situation like that, then our question is, well, one, I need to use $310,000. So how large of a loan do I need to take out if you're going to take 20% of it and say I basically can't use that even though I'm paying interest on it? And two, if you do this 20% thing, I only get to use some of the money that I'm actually going to be taking the loan for. And so what's going to be the effective interest rate? In other words, how can I compare this loan to other types of loans that might be more standard types of loans? And for that, we'll use basically the effective interest rate type of calculation. So that's going to be our scenario in a nutshell. Let's go over it one more time. We got the funds needed to borrow. This is going to be for a year, so we're going to have the loan nice and easy for exactly a year. $310,000. The interest rate's going to be 12%, but there's a compensating balance required of 20%. What is the effective rate of interest? Now, we could figure the effective rate of interest two different ways. We can do it kind of abstractly using the percents up top, and then we can use it, and then we can do it by actually calculating what the interest will be on the loan, and then figure the effective interest method after we know the cost or the interest on the loan. So let's first think about the effective interest rate, and we'll use this basically taking these two rates and thinking about, okay, well, if you got an interest rate of 12%, but there's also a compensating balance of the 20%, what is the effective interest rate? I want to know that so that I can possibly compare it to other types of loan possibilities we might have. So the calculation for that's going to be the 12%, the interest rate, and it's going to be divided by 1 less the compensating balance percent. In other words, 1 minus 20%. Let's put that into a little table here so we can work through this. We're going to say that. Here we are in OneNote. If you would like to follow along in OneNote, you're not required to do so, but if you have access to it and would like to, we are in the 822 Compensating Balance Loan tab in the Practice Problems section. Closing this back out, we're going to have our information up top. We'll use that information to work through the problem down below. Basic scenario is going to be that we need $310,000. We want to actually use $310,000 that we would like to get in a loan. The bank is saying, hey, there's some risk to us giving you a loan for $310,000. In order to mitigate the risk to the bank, they may, for example, increase the interest rate, or they may have some kind of fees, or they may structure the loan a little bit differently. In this case, they're going to structure the loan in a way that we have a compensating balance that will be required of 20%, basically meaning that although we're going to be charged interest on the entire loan balance, 20% of it is going to basically be not usable, because that'll give some assurance to the bank that you'll at least be able to pay back the 20% at the end of the time period. So then a couple questions arise if we're going to have this kind of situation. First is, well, if I need $310,000 to do what I want to do, because it's like, you don't understand, I need to actually use the $310,000. And if you're telling me I can't use 20% of it, then the question is, well, how much do I need to borrow so that you can then take the 20% out and I still have the 310 that I need to do stuff with. Also, we want to say, okay, well, whatever the loan amount is, can I compare that to other loans that don't have that kind of funny thing going on there? So we want to standardize the loan. We typically use our effective interest rate in order to do that. So this is going to be our scenario. We got the funds needed to borrow are $310,000. We're going to have to figure out then how much of a loan we're going to need in order to get the actual $310,000, given the fact that we have an interest rate of 12%, but we also have this compensating balance requirement of 20%, which basically reduces the loan amount that we're going to actually need to be paying interest on that we actually get to use. So first, we're going to think about the effective interest rate method. Now, there's a couple different ways we can calculate the effective interest rate. We can do it kind of more, I would say, kind of abstractly using the interest rate and the compensating balance percent. And then we'll get into it a little bit more concretely by actually figuring out what our loan will be, picking up the loan amount, and then we'll figure out the interest or the cost on the loan, and then we'll figure out what our effective rate given the cost of the loan is, as is more familiar or kind of easier to think about after doing some of our practice problems in the past. That's going to be our standard kind of format. So first, let's just think about the effective interest rate kind of abstractly before we even have the loan amount. We can do that by taking the interest rate divided by 1 less the compensating balance, or 100% minus the 20%. 1 minus the 20%, the compensating balance. Let's work that in a little table here. I highly recommend doing this in Excel and working these little tables in Excel. Great practice to set these up. So we have the interest rate is going to be 12%. Then we're going to say 1 less the compensating balance percent. I'm going to do that with a little subcalculation, 1 or 100% minus the compensating balance, which is going to be 20%. So 1 or 100% minus 20% or 0.2 is going to give us 80%. So now we're going to be taking the 12, the interest rate, divided by 1 minus the compensating balance percent, or 80%. So let's do that real quick. Just be careful with the decimals and the percentage. Just in decimal format, it would be 0.12 divided by 0.80 or 0.8. And that would be 0.15, which would be 15% if we move the decimal over 2 places, 15%. Okay, so now that we have that, now let's think, okay, next thing, and why is that important? Because now we can, of course, use that 15% as more of a standard method that we might be able to compare against other loans that we might be able to have normal kind of financing to. So we want to standardize these different funny loans to try to see if we can compare them better by getting a standard, basically effective rate. All right, so now let's think about, well, I need $310,000 to do what I want to do. I want to like do stuff with it. And if you're going to tell me that I can't do stuff with the $20,000, I got to basically hold on to that and like an account not use it, basically, even though I'm going to be paying interest on it. The question is, well, how much do I need to borrow then so that I can use the $310,000, right? So the idea is, of course, that I need a loan that's going to be large enough so that when you take 20% of it, I'm still going to be left with the amount I need in order to do the thing that like I want to do. So the formula is going to be, I need $310,000 divided by 1 minus the compensating balance percent, or 1 minus 0.2, or 100% minus the 20%. So the $310,000 divided by the 100% minus the 20%. Now, if you were to write that down or think about it algebraically, you might think about it this way. You might say, well, I need to get some number, some loan amount, which would be X, minus the loan amount times 0.20, because that's going to be 0.20%. That's going to be the amount they take from the loan that I don't really get to use. And then I need to be left with, that's got to equal the $310,000. And if you solve for X, then you could factor out the X. X times 1 minus 0.2 in this case, 20%, 0.2 equals the $310,000. And that gives you with X equals the $310,000 divided by 1 minus 0.2. So the end result then that you can memorize, or you could think about it this way if you want to go through the algebra, this is the way you probably derive that. It would be the amount of money that you want divided by 1 minus 0.2 of the compensating balance required. Let's put this formula into a little worksheet then. We're going to say, all right, the money that is needed, which we're going to basically call the principal. Now, note that when we start thinking about this formula down here, the principal factor gets a little bit confusing now, because now we have the loan amount that we could think of as kind of different than the amount of money we get to use. So the term of what is the principal amount gets a little bit confusing. We're going to say the money that we need, the money that we get to use, is going to be basically the principal. And then we want 1 less the compensating balance percent. So that's going to be just 1 or 100% minus the compensating balance, or 0.20%, 0.2 I'm sorry, 0.2 or 20%. So that'll be 80%. And then if we take our 310,000 divided by the 80% or 0.2 with the giant calculator here, we're going to say the 310,000 divided by 0.8, that's going to give us our 387,500. So we need a loan for 387,500 so that when they take out the compensating balance that we don't really get to use, we're going to get the 310,000 that we actually get to use to do what we want to do with. So to double check that, we can say, all right, well, does that make sense? What if I had the 387,500? Then they're going to take 20% times 0.2. That's going to be the 77.5 that they're going to take, basically. That, you know, basically I can't really use it even though I'm going to pay interest on it, is what that means. So I'm going to say then minus the 387.5, that gives us the 310 that we actually get to use. So that makes sense. So now we're going to say, okay, now I know what the loan needs to be, the 387.5, so I can get the amount that I would want to use, the 310. So now that I know that, we can say, well, let's figure out the interest rate then on this. What's going to be the interest rate? And then let's figure out our effective interest rate again, now that we know the cost of the loan exactly. So now that we know the loan amount, and notice again, the loan amount is this, that's what they're going to be calculating the interest on, even though we only really kind of get to use the 310,000. So that's what's going to be kind of the confusing component here. We're going to calculate interest. That's going to be this formula. I equals P, or the loan, times the rate. That's for a year. Now this is exactly a year-long loan. So that means the time, which is a ratio of a year, if it's going to be less than a year, is just going to be 1. So time will not be a factor. It's just going to be 1. So we got the loan amount is going to be the 387.5, the amount we just calculated up above, and then the interest rate is the 12%. We don't have to worry about time because time is simply 1 here because it's for 1 year. So it would be 360 over 360 or 12 over 12 or 1. And so the interest is going to be the 46,500. So now that we know the interest, which is the rent on the loan, basically the cost of the loan, what we're paying for the purchasing power of the money, which is the 387.5, even though we only got to use the 310. And now we can think, well, let's calculate the effective interest rate now that we know kind of the cost of the loan, because that's how we normally calculate the effective interest rate. It's kind of easier to see that way, and we should get to the same number we did up top when we calculated the effective interest rate in kind of this more abstract type of format. So the confusing thing here, once again, is when we think about the effective interest rate, we're going to rework this formula to the rate equals interest divided by P times T. Now, P is going to be the interesting factor because that's usually the loan amount. But what we want to do is see what the cost is on the amount of money we kind of get to use, which is the 310,000. So P here, we're going to be using this 310,000. Remember that T, the time, is simply 1. So it's going to be not too difficult to figure the time factor. So we're going to say the interest is going to be the 46.5 that we calculated up above. The amount we get to use, the principal, is going to be the 310, not the loan amount. We're comparing it to the principal because that's kind of what we get to basically use. And so if we divide that out, we get that 15%, the effective interest rate. That 15% being something then that we can compare to another loan that we might be able to get for like 310,000 and look at the interest rate that they provide us and try to compare apples to apples or the same thing to the same thing when we have these different kind of loan terms where the bank's giving us these funny loan terms. All right, so let's think about it again. Let's do another one, similar process. We're going to say, okay, the funds needed to borrow for 1 year, we want 150,000. We want to actually use 150,000. Bank says, hey, you're a bit of a risk. I don't know. We want to do something to mitigate our risk. The bank often, to mitigate risk, might increase the interest rate. They might have some kind of fees. They might change the terms of the loan. In this case, they want a compensating balance of the 19%. So they're going to say, we're going to take whatever loan we give you, we're going to take 19% of it. So then we say, okay, well, I need 150,000. So how big of a loan, first of all, do I need to take in order for me to be able to keep 150,000, since you're going to take 19% of it and basically put it in somewhere where I can't spend it, in essence, is the point, so that they can have less risk on it. So basically, then the question is, well, how big of a loan do I need? I need higher loan than 150,000 if you're going to take 19% that I can't really use to do the thing that like I wanted to do with it. And then there's going to be a 17% interest rate. but I want to know the effective interest rate. I want to be able to compare this funny loan to like other loans on like normal loan standpoints so that I can see, you know, what it's actually costing me and have it make sense in my mind. So that's what we want to look at, the effective interest rate. So we can do this effective interest rate again, like kind of abstractly before we even figure out really the loan amount that we're going to have. So let's do that, and then we'll figure out the loan that we need to take, you know, in order to get $150,000 we actually get to use, and then we'll figure out the interest on that, the interest calculation, and then the effective interest rate based on the interest calculation, the cost of the loan. So first we're going to be thinking about then the effective interest rate with this kind of more abstract calculation with the percentages. So we're going to say that's going to be the interest rate divided by 1 less the compensating balance. So we're going to say the interest rate is going to be 17%. And then we're going to say 1 less the compensating balance. So I'm just going to say 1 minus the compensating balance percent, which is 19%. So 100% minus the 19% or so will give you the 81%. And then if we divide that out, we're going to say, all right, now we've got then the 0.17 divided by the 0.81, and that's going to give us our 0.299 about. So now I can compare that. I can say, well, if I look at another loan, I can compare and contrast and see if this lines up to what you would think would happen with another loan a little bit more easily. But I would like to basically to figure this again once I know the actual cost of the loan I'm actually looking at, because that makes more sense to me. So I want to actually figure the loan amount and then the interest on it, and then figure this rate again using. So now we're going to so we want to actually use the $150,000, and so we want a loan that's going to be large enough so that when they take the 19% that I can't basically use, then it's going to leave me with the $150,000 that I can actually do what I want to do with it. So then to do that, there's the formula. The end result of the formula is going to be, you're going to take the amount of funds that you want, divided by 1 minus the compensating balance required. Now, if you were to derive that, you'd go through this thought process. You'd say, okay, well, what's the loan amount? Loan amount's going to be the X that I don't know, minus like 20% or the 19% of X times the compensating balance requirement would equal the amount that I need, 150,000, right? The loan minus 19% of the compensating balance of the loan. It's got to leave me with the 150,000. Factor out the X would be X times 1 minus the 0.19 or 19% equals the 150,000. X then equals the 150,000, the amount of money we need, divided by 1 minus the compensating balance, or the 19% in this case. So let's do that in a little table down here. We're going to say, all right, let's put this formula into like a little table. We're going to say the money we need, which is going to be the principal. We're going to call it the principal, which is a little confusing when we look at our data down here, because the principal and the loan amount, you know, you could think of them as a little bit different, because we're going to be paying interest on kind of the full loan, but we're only going to get to kind of use the 150, 1 less the compensating balance percent, so 1 minus the compensating balance percent, 1 minus the 19, that's this component. That's going to then give us the 81%. Then if we were to divide this out, pulling out the trusty calculator, the huge trusty calculator, we're going to say that we have 150,000 divided by the 0.81. Divided by the 0.81 is going to give us about the 185. Now, if we double check that, we're going to say, okay, if we took out a loan then for the 185, and they took then 19% and put it and made it so I can't really use 19% of it, so times 0.19, that's going to be the 185 minus the loan amount, which was the 185 about, is going to be about, you know, the 150,000 that I actually need to do stuff with. So now the loan that we're going to pay interest on is the 185 about, and the amount that we're going to get to use is the 150,000. So now I want to figure out what the interest is going to be on that. I got to use the loan amount to figure the interest. Then I want to calculate the effective interest rate, figuring that on the amount I actually get to do with what I want to do with it, the 150. So let's go down and say, okay, well, the interest is going to be calculated I equals P, which is the confusing component, which is actually going to be the loan in this case, times R, the rate for the year, times T. T is just 1 because this is going to be a 1-year loan. So we're going to say then the loan amount, the 185 about, times the 17% rate means that the interest will be the 31,481. 31,481 is going to be the rate. Now we're not going to multiply it up times T would just be 1, so it would be the same. Now we know the cost of the loan. Let's compare the cost of the loan not to the loan amount, but rather to the amount that we get to basically do what we want to do with, and use that as our calculation of the effective interest rate method to see, you know, we can then compare that to other loans that would give us the money of the 150,000, you know, that we'd actually want to do stuff with. So now we can do that effective interest rate calculation again, which will get to the same number we saw above, but I think this is a little bit more straightforward to see. This is going to be this calculation, R equals interest divided by P, this time being P, the amount that we get to use, times T. T is going to be time. It's 1 because it's 1 year in this case. So we're going to say the 31,481, and the amount we get to use to which is the principal, the 150,000, not the loan amount, but the amount we get to use. The 31,481 divided by the 150,000 gives us an effective rate of 20.99. That should match the effective rate we did up here with the other method, same effective interest rate. And that can help us to standardize this loan. So if we compare it to other loans that have different funny kind of financing terms or whatever, we can try to standardize them and be comparing them together on the same effective rate terms.